Alright, should be making a video. Yep, appears to be working. So, yeah, I'm going to talk about something. It's really elemental to all these subjects, so if you really don't get this part, then yeah, talk about something where you're going to fail to get an awful lot of recognizing that, this whole idea of the Descartesian view of energy in the universe and how it's just recycled, and it's the same energy, same amount of energy, it's a constant amount of energy, and it just changes. And they use the word form, but it really doesn't change form. It just changes how big of an object is being pushed, and that's all it changes. You can push little things or you can push big things. And pushing big things mean you're pushing the little things inside. So in a sense, it's the same thing. It's just matter being pushed. It's just that you have more of it, or it's a higher density. So it really is like fish and school of fish. The fish have to do the schooling. The fish are the things doing the moving, always. And what we're really just saying is that there's a force that sticks to the fish and moves the fish. You could say, instead of the fish having fins and moving itself, it has to be fueled by something called energy, or force, be another word. So I can go over all of these different ways of trying to get to that point, and so I guess I could talk about all the subjects eventually, because they all have some component that relates to this understanding that force is carried by matter. And I just don't know, it's hard for me to imagine how you don't imagine the universe working that way. So you have something like an electron or a proton, and the idea is that thing itself can't just, grow an exhaust port and start shooting itself around. That it has to interact with something, and the idea is it interacts with a force. And so I think you could understand that if there were two electrons, there's something between them that's causing repulsion. So it doesn't matter, like, you don't have to understand this to be a real force between them, something that's, you could argue, is just moving back and forth. Let me use this here pen, maybe. Maybe you should use the red one, Gary. Well, how about orange? That's almost red. That there's something going back and forth, little bits, okay? And the closer it gets to something, the fact is it keeps hitting more times. Now, I would argue it doesn't really hit more times, it sticks, but there's a constant new generation of more bits. See, now I could go through the whole charge thing again, but it's just, it just ends up just adding a complexity, and then people just get turned off because they say, well, I don't have to believe there's no blue and red things. I mean, I could explain to you that there's two kinds of object, the proton and the electron, and the real catch is there's actually two kinds of force, okay, and the two kinds of force do exactly the opposite thing to these two objects. So the idea is that if the black stuff goes right through the orange thing, but the orange sticks to it, and the black bits stick to the black thing but go right through the orange thing, and the orange bits go right through the black thing, then you could understand, well, if you thought about it a little tiny bit, that, in this circumstance, no black bit can hit the orange bit. I mean, no orange bit can hit the black bit, because every time the orange bit goes through, it changes to a black bit. So no black bits could hit this surface, and no orange bits could hit this surface. No, exactly the other way around. No orange bits could hit this surface, and no black bits could hit this surface, and therefore there'd be no pressure between them, and that's why they attract. And then you could understand that if I had the exact opposite circumstance of two electrons, for example, that now all the orange bits turn to black bits. So you can understand that all the orange bits are going to go through and turn to black bits and stick, and all the orange bits from this side are going to stick to this one because they're going to turn to black bits. So you can understand it creates a tremendous amount of pressure pushing them apart. And that's how you end up with a simple mechanism that creates both attraction between electrons and protons and repulsion between the protons and the protons and the protons and the electrons and the electrons. Anyway, let's see. It's so simple to me, but yes, I'm asking you to, believe in 2 plus 2 plus 3, and that's too complicated a number, 7, something like that. And there's just 2 kinds of force, 2 kinds of matter, and there's only 3 possible interactions. It sticks, it reflects, or it transitions. That's it. All right. But anyway, so back to the argument. So the simple idea is that it just seems really intuitive to me always to understand that the speed of light stuff was little stuff, all right, and it hits electrons and protons, and you don't have to understand all this mechanism to basically just understand that that is what makes them move, and that the force is carried by the matter. The matter gets it stuck to it or incorporated into it. It doesn't really matter how you understand that. And that this was going the speed of light, and this isn't going to go the speed of light. It's going to be less than, okay? And, basically this is the mechanism that's happening, holding atoms together, and then it's, if the atoms are surrounded by electrons, you can understand, so they're sort of like, they're positive in the center, net positive. There are still electrons in the center, but, So again, regular physics, they know that a neutron decomposes into an electron and a proton, and yet they won't concede that it's made out of electrons and protons, not quarks. It just doesn't. And, an electron and a proton is essentially, you can understand, it's a dipole. It's a plus stuck to a negative. It's a north stuck to a south. I mean, it's not even a little bit challenging. Alright, so where I want to get to is the idea that heat is just momentum, because it, again, is just converting motion. It's taking some big object that has a net amount of mass and velocity in a direction, and it's just converting it to a bunch of little things that have a mass and a velocity. And that's all that's happening. There's nothing else happening. And so every time you create heat, you have to say, well, where did the momentum that caused it come from? You can't just magically create this thing called motion. You can only transfer the motion. So you can even think of the little bits as a virus, and something hits something, like in the Newton's cradle. One of them's got the virus, and it gives it to the other one. And that's it. It's just a force you carry. And you can transfer it sometimes very easily, and then sometimes the transfer is very complicated. So that's elastic and inelastic. And that's where you end up, like sound, or like a lot of other things, you could sort of understand, like even something being aerodynamic. You can understand the difference between something being aerodynamic and going through the air efficiently, and something that tries to go through the air, but because of its shape, it ends up shooting energy in all kinds of directions, and it ends up just dragging to a halt because it loses so much energy, where the more efficient thing stays going straight. The thing with less friction or less rubbing, where you're taking the energy and extracting it. But that's all heat is usually in a circumstance where you're creating heat because you haven't hit maximum efficiency in terms of the path you're taking. It's too it's too low a velocity, which means you're sticking to things. So let's say if I had a bunch of magnets in a row and I wanted to throw a magnet through them. If I throw the magnet slow, it's going to not get anywhere. And if I throw it fast enough where it still gets through, you can understand it's going to wobble all of those magnets. So as it goes through, it's not only going to be affected by that force, it's going to affect the magnets too. So they're going to move. So that would be like friction. And then if I go even faster, well, then I'll defeat that process, because the magnets need time to say, I'm magnetic. Just like it takes time for you to weigh your mass. You can't weigh your weight instantaneously. It takes time to exchange your force. That's how we measure your weight, is to collect your force. Now, if I collect it with friction or I collect it with a spring, it doesn't matter how I collect it. It's never going to be collected instantaneously. It takes time to make the transition. Except in the case of, say, a Newton's cradle, where I make the exchange with something that's exactly like the same exact thing. So all of the arrangements, all the proportions are exactly the same, so there's no conversion problem. You're not converting euros into dollars, or you're not converting dollars into nickels. Yeah, so that's one way of saying it. Whoops, I was erasing. That wasn't what I was doing. But yeah, so it's essential to, like the ballistic pendulum argument, I guess you can't get it if you don't understand that if the pendulum has thousands of joules worth of heat inside of it, the argument would be heat has to be created by momentum. It's movement. You can't make the movement from nothing. Something had to give it the movement, just like a bowling ball hitting a bowling pin. I can't hit the pin and keep the bowling ball's momentum. It has to lose its momentum to the pin. So whatever the pin leaves with, the ball loses. Just like the friction of rolling a ball, whatever the ball loses, the ground has. So it always has to come from somewhere. So the simple argument is in the ballistic pendulum, when it fails catastrophically, okay, to ever move with any kinetic energy, that's not a very good KE, 0 KE, it will be no KE over just the momentum. So if you understand that, I guess I should use the P, the MV, yeah, there, I'll fix it. So it doesn't matter what I put in here. So I put in a 10 mass going 5, or I put a 5 mass going 10. I put a 0.04 mass going 4 million. It doesn't matter what I shoot into this thing. All I ever get is the MV in the pendulum as motion. So the only part of the linear line I save is the linear momentum. And all of the kinetic energy is not apparent. It doesn't do any motion work. And their argument is, though, is a bunch of heat is created. Now, they never measure it, of course, and so obviously the simple solution is to actually measure it and prove it exists. But they'll never do that experiment because it'll prove it doesn't exist. But anyway, if they believe it happens, and let's just say this is 2 joules of momentum and 2,000 joules of kinetic energy. So it's a gigantic amount of kinetic energy. And you're saying, well, if I have 2,000 joules of heat and I only have 2 joules of momentum, you can understand, well, that's 1,000 times more energy. That somehow I used, what momentum created it? Where did it come from? I mean, how did you make all of this heat? Because now in the universe you have 2,000 joules of heat and you have 2 joules of linear motion. So somehow you started with just 2 and now you have 2,002. And that would be free energy. You can't increase the momentum in the system, right? The whole system can't have more momentum in it. And so the simple argument is heat is momentum. I can convert heat into work. It's a fact. And so therefore I started with just 2 units of momentum, the energy required to make 2 units of momentum, and now I have 1,000 times more units of energy to make momentum out of. And that would be just obviously free energy. Yeah, I was, But like I said, if you don't understand that heat is just a transition, it's just taking what you had and you have a big thing moving and you just convert it into a small thing moving. And that's all it is. And the radiation coming off of us is almost proving the case, because you can have a camera that can see the infrared, and you can actually just measure the radiation and say this is how hot you are. The radiation is itself the heat. You're actually collecting heat. You're collecting little units of momentum. That's what you're measuring. It's momentum. It's capacity to cause movement. That's what the photons are. They have a capacity to cause movement. They have momentum. Yeah. That seems reasonable to me. So we have one chatter. Came in really early, really quick, but nobody else. Oh, it's the Atari guy. Okay, yeah. All right. So the heat argument works for gravity. It works for, like I said, all of these subjects. So I guess I'll do the gravity thing real quick, just to point out that that's where the heat cycle in the big universe, that's where you can see it happening. And let's use, all right, the yeah, it's, the only part that's complicated is the timing part. Okay, so we'll use orange for now. This is the heat going into the earth now. All right, and then you could understand that it's coming from all directions, little bits of energy in the form of this discrete photonic type stuff. You can't see it like infrared. You can't see it without a special camera. So there's lots of this stuff in the universe we can't see because it doesn't come at a frequency. It doesn't come at in some way that allows us to create an instrument that can see it. Okay, and it's sort of like you can sort of understand why that is, just as you could understand that if you're 50 degrees and something is 50 degrees, you can't tell the difference between you and it. You're blind to its temperature because you're creating the same effect that you're trying to measure, and the two things, it's like almost jamming a radio signal. Lots of ways, I think, to understand that there's reasons why we can't see the native energy in the universe is because we're excreting it. Every piece of matter has it. So there's nothing you can make that doesn't have it, that isn't like exposed film. You can't make a picture with film that's already exposed. All right. So energy comes into the Earth. And what happens is through the process of going through the Earth, it is slowed down by that simple process that the stuff going the speed of light goes into you, pushes your little atoms, they push into the Earth, and it takes time for all that to happen, going all the way through the Earth, moving matter. All right, and it's coming from both directions, obviously, so you can get sort of the idea that you have a bunch of movement going this way, in and opposing each other. And you know that opposing movements aren't great. That's like car crashes. And you can sort of understand there's lots of bouncing around. So they're all kind of elastic. So it's like bumper cars. And you could sort of understand if you had a big, huge arena and you had a bunch of bumper cars and they're all crashing into each other, you can understand you have all kinds of motion you can't get rid of because it's stuck. It keeps banging into stuff, and it takes it a while to radiate out, back to the surface. So it starts on the outside, goes in, and it takes a while to get the hell back out again. And so that would be this transition, that it comes in now, and it comes out later. So, and you could understand that if I turned off it's like a phosphorescent substance. I can expose it to light and it'll radiate, when I turn the light off. Because the energy is still inside the substance and it's leaking out over time. So it stored energy in a sense that it came in now, but it's not going to come out until later. And the same thing's happening on the Earth, and that's what you're falling into. So what Newton discovered was the actual, the amount of that differential, and it's the, on the surface, it's 9.8, okay, meters per second of velocity, but it's, just velocity over 1 second. So every 1 second in this differential, you will be given 9.8 meters of velocity, and you will move 4.9 meters. And as you keep acquiring velocity, you'll keep just getting 4.9 meters and 9.8 meters of velocity. This is all you'll keep doing. You'll just keep doing it over and over again. So you can understand that the first bit you get gives you 4.9 meters. But it gives you this velocity, so you're going to get the next 2 units of distance for free, because you already have the velocity. And then the third unit you're going to get, because it's another second. 1 second here, 1 second here. Every second you're getting 1 more unit of 4.9 distance and 9.8 increase in your velocity. And Galileo discovered that, and it's 1, 3, 5, 7. It's just the odd numbers forever. Because all you're really doing is just saying you just keep adding 1 more unit of distance per second, but you're compiling a velocity. And so in the first unit you get 1, and in the second unit you get these 2 units of free motion. Then in the third second you get 4 units of free motion, and then in the fourth second you get 8 units of free motion. It just keeps going that way. Doubling. Alright. So now I've sort of gotten the 2 subjects connected to each other, but you could understand that if I turn the red force off, the now force, you could understand the Earth is still going to be radiating for a while. That's the differential. So it's a constant fueling process. This can't stay hot unless it's constantly doing this process of collecting heat. That is, having the pushers that are pushing right now are replaced right now. This next 1 second, these pushers that are now pushing stuff inside the Earth are going to be replaced by these new ones that are going to do the pushing. So it's constantly fueled, the heat. And that process has a delay in it. And that's it. That's all there is. There's always a constant delay. That means there's always, at any one exact moment, there's this differential in the force coming in and force going out. But it's only for this moment. And eventually, okay, a moment later, it'll go back to equal. And because the universe is constantly doing this, well, a moment later, it's unequal again. Because it keeps refueling. So it's just a constant process of creating that differential, then bringing it back to neutral, and then you're back to a deficit again, then you're back to neutral, and then you're back to a deficit. But it's just that process. So you could just understand that's how the universe is basically working as a heat engine, is that it stores a little bit of heat in matter, and that creates, because of the taking, not letting it out at the same time, and that the universe is just basically doing this pushing thing. It's pushing, but it's getting it all back a little tiny bit later. So it's an equal process. It's all the same energy. It's all the same amount of force, and it's just creating this little oscillation where it pushes, goes back to 0, pushes, go back to 0. It doesn't go back to where it gains more. So it never pushes you back up. It just stops you from moving. And then you move again, and then you stop, and then you move again, and then you stop. All right. It really isn't that complicated. I guess the thing to understand is this simple idea that you could understand that if I'm sitting here on Earth and I'm exposed to the raw universe here, and the universe that's on the other side of the Earth has to go through the Earth to see me, to get to me, to shoot a ray beam, to shoot rays at me. You could understand that, oh yeah, there's probably this huge likelihood that there's going to be less stuff coming at me from underneath because it has to go through all this earth. And that it's really easy for it to get to me from the top. And that's gravity. Right. So that's probably enough. Yeah. Okay, still no chatters. Yeah, these rooms just aren't popular enough. Probably just not worth it. See, I just wanted to do this for my own organization of the argument. Because again, this heat thing is the thing that really is, it's really the core of it, the thermodynamic argument that underlying everything else, you could just think of it as all thermodynamics. If I move this pen, like the school of fish, it's individual fish moving. And all I do is, there might be all kinds of stuff, heat, there might be all kinds of movement inside of this pen, and all we're saying is there's a net fact that more stuff is hitting this way than is hitting it that way internally, and so it goes this way. There's just more fish that on average are going this way more than they're going that way, and that's all you need to move the school. And and that differential can be given away to anything. It's just the small stuff moving, and I can just give away the motion, and now this fish are moving slower because I gave away some of it. So motion is just force in the same direction, right? And heat is motion usually in all kinds of directions. And so it's a little more complicated. But that would connect exactly to the pressure argument. That you can pump something up with pressure. And you do know that that's all it's doing is everything's just hitting all the surfaces. And if I have a certain amount of motion in there and then I make the container smaller or I make the container bigger, you could understand that it's not going to hit as often if it's bigger. There's going to be less impacts per unit of time on this surface if I create more room for the things to move around in. And so the pressure is going to reduce. The amount of pushing is going to be reduced. And I can clearly just, I can make a hole somewhere. And you can understand that these pieces are bouncing here, bouncing here, bouncing here, bouncing here. They're just moving all through it. And eventually every bit of energy will hit every surface. So if they were all different colors, the argument would be over time, red would hit here 5 times, blue would hit here 5 times, purple would hit here 5 times, because it's all just chaotic. And so if I open a hole, okay, you can just understand that it's all going to be ricocheting around, and all the stuff hitting this surface or this surface or this surface will all still hit this surface, and the catch is it won't hit this surface. So you can understand now I've changed the net circumstance. I'm going to have more impacts, more pressure here than I'm going to have on this surface, because this surface is not going to have an equal number of push arrows hitting this interior surface than this surface. So it's going to move in that direction. And it doesn't matter if I take this and create a hose, because the hose also has the same chaos in it. It has all this ricocheting going on. So all the directions are still in here. I haven't lost any direction, okay, because I make a hose. And so I'm still just going to release it in one direction. And so I've taken all the energy that's going in all kinds of directions, and I've converted it into one direction. And we know, hey, that's really useful. That's like the piston going up and down. You make it into a circle, blah, blah, blah. I can use that where I couldn't use this. Going everywhere doesn't help me much. But going in one direction, that's very helpful. That'll make something move in one direction, and I can smash it into something else. I can do something with that motion. I can't do anything with this motion. So in all our human cases, we break this simple cycle So the energy always exists. It's just that we have a hard time making devices capable of collecting it all and returning it into one direction. So it's when energy is turned into other directions that it becomes less useful. So I guess I could use water waves. So water particles are kind of stuck to each other loosely. And the idea is that if I compress them, that as I splash something in here with a force, you could understand that the water can't be compressed. It's almost uncompressible. Obviously, it compresses a little bit. I wouldn't say obviously, but it obviously has some elastic component. And the fact is that it's going to move in a direction, but it can't move into higher pressure. So as it's moving into this other water, this water's been compressed. You push this water into this water and this, so it's been compressed. The compression can't keep going because it's uncompressible, and so it just is as it exists, just like an electron. If I put an electron in space somewhere, it's going to see where there's the most proton force and the least electron force. It's going to find, like a magnet. You couldn't, if theoretically, if everything was magnetized, you could sort of understand I couldn't put a magnet anywhere, but it would go somewhere, because there's never going to be a perfect equality in all directions. There's always going to be some direction that's preferable. And the water is experiencing the same thing. So when I increase the pressure here, it's high pressure, the water has to go this way, but it can't go down because the ground isn't going to compress, so it has to go up. And so that's what creates the lump. And then once you create the lump, as soon as the pressure reduces, the water will go back down, increase the pressure again, and now, well, the increase in pressure means it has to go back up. So, there's a whole mechanism to it, but it's all starts with energy in one direction, and it gets turned into energy moving in all kinds of directions. And so that's the dispersion part of the argument. So again, it's you could argue that shooting a bullet into water, doesn't really matter, or gel. You shoot something going very fast into some substance, and you'll find that it goes a very clean path while it still has a high velocity. But as it slows down, it starts to create a bunch of turbulence in the material. It starts to, because it's sticking more. The material has time to stick to it. It has time to interact with it. So if you're going fast, there's very little interaction. That's like me going fast through two magnets. I have a magnet, and I go fast right through the magnets. I won't feel the magnets because they won't have time to interact with me. So you can't, if you go too fast, the force can't interact because it's a time-dependent force. The speed of light is fast, but it's not instantaneous, so it always takes things time to react. It's probably a better example of something more, well, you've probably experienced it. The faster you jab something with a stick or something else, the further it goes in because there's less friction. Is the simple truth. Your part of your path is unencumbered by this sticking force. So anyway, so this is essentially the heat part. So slow speeds end up creating dispersion. So there's the energy starts dispersing in all kinds of directions, and now it becomes very less useful unless we do something to collect it, unless we create some kind of bubble that it hits, and then we can bounce it around and then let it out one hole. Kind of like lasers. Okay, lasers are a little like this, but I don't want to get into the whole complexity of lasers. But there'd probably be a pretty good example of this effect of taking dispersed energy and focusing it in one direction, forcing it to leave in just one direction, allowing it to leave in just one direction. So this gets me back to the ballistic pendulum. So if I was to just crash a car, into a gigantic ballistic pendulum, it just doesn't matter what I use. all I can do is collect the momentum. So in no ballistic pendulum ever conducted, no experiment, have they ever collected any energy above just the momentum. So even though the KE is always more, none of it's ever collected as linear motion. So the first argument would be they can't say that KE is about doing work, because in all of these examples it fails to do what we call useful work. And the only thing it does create is heat. And most of the time the argument is heat isn't usable. Now that's the point that I'm going to make. So we start with 2 MV here, we get 2 MV here, so we conserve the momentum. But the question is if I did create a joule tank or some kind of container that could collect the heat produced, any extra heat created by the experiment, again, their argument is that I'm going to collect 2,000 joules of heat. And I only start with 2 joules of momentum. And that's the part where it just doesn't make any sense, because I can convert the heat into momentum. I can open a hole here in this heat machine and I can create real momentum, real movement. So I started with just 2 joules of momentum, and I'll have 2,000 joules of momentum, and that's not possible. The conservation of momentum, conservation of movement in the universe says that can't happen. So if you believe in conservation, you'll understand that yes, you can't make free motion. Pins can't fly without getting hit by bowling balls, and bowling balls can't keep their energy if they hit pins. It's really that simple, and it's a little bit pathetic that I have to make these videos. Yeah. Alright, we have a couple of comments. Hello. Well, I'm not terribly interested. But hello, whatever. The force bits entering the Earth being stored. So technically it's not really storage in the sense that it happens constantly. It's not really stored. You're just arguing that this is what happens to the energy. You put it in on the outside, and it takes time to get to the outside again. And it's constantly doing that. So it's always a little behind. So it's not really about storage. It's about increasing the density, you might argue, right, in some sense. Let's see. Slowing it down means you inevitably create more density, right? So we could make that argument that if it's going in with a frequency, and if it's slowed down, it means that it has to be at a much higher frequency inside because of that process of slowing it down. So, that would be a way of visualizing. So I've increased the density a little, but I'm constantly doing it, right? The density is relieving itself. It's expiring. Just like you getting pushed into the ground, the force expires. You don't keep it. You give it to the ground, right? There's not something else happening, right? You give your force to the ground. So you've dissipated it again, and you're back to zero. And then the force goes in again, and you dissipate it into the ground. Alright, so, so that should be enough of an argument for that part. Let's see what else he says. The force bits entering the Earth being stored. Okay, so I'm not sure. Like I said, storage is it's stored from now to a millisecond from now, their storage. But technically, it's not permanent storage. If I turn off gravity right now, the Earth radiates what should have been radiated a millisecond ago. Alright, let's see. And radiated sounds similar to a capacitor. Ooh, that's a little bit dangerous because, a capacitor is a buffer. And I don't know if I'd call the Earth a buffer. Well, it's the same, right? It is, in a sense, it's a buffer in the sense that it is changing the density, which is changing the time or changing the phase. So I guess in some respects. In a dynamo hub that stores mechanical energy, then releases it. Yeah, obviously the Earth doesn't, there's nothing variable. The Earth was built a piece at a time, so the Earth wasn't like a big blob and then you had to heat it up. So there was no like preheating the Earth, you know, where, oh, it's cold and I have to take a whole bunch of energy to heat it up. It was created a little piece at a time, so it got hot a little piece at a time. All right, and all you're talking about is how do I maintain that fire? So there's a fire, it's already built. We're not talking about what it took to get it started. It's already flaming, and you're just saying how much energy do I have to put it in to keep exactly the same size flame. All right. 6 a.m. Good morning. Well, you know, I don't know how interesting that is, but fine. Let's study. Anyway, I understand high density makes more sense. Okay. Whatever works. You know. Because you could turn into a phase argument. You could turn into a lot of arguments. And, you know, the phase argument gets into the whole drag argument. You know, I'll just do that real quick, just because, you know, I haven't. It's going to be a little while in the simulation. There's all kinds of troubles people have, and so, you know, blah blah blah. So there's a bit of a delay. But the idea is that, you know, there's a certain amount of stuff to push on both sides of an object, and so if it's going to plow into one direction, the theory, the Feynman statement is, well, it's going to hit more stuff here. But again, it's a timed story. So it's only going to hit more stuff, okay, while it's moving. And as soon as it stops moving, you sort of understand that all the stuff that missed it over here is now going to hit it. So it's going to get hit by the same amount of stuff. It's just whether or not you're saying over time what happens. So it's, you know, like I said, as soon as it stops, all of the force that was out running hits it. So you could sort of understand that obviously it escaped force, but it didn't really escape it forever. It only escaped it while it was moving. And as soon as it stops moving or slows down, all the stuff that escaped is going to hit it. Now the problem with the simulation was I used one frequency, and so what I ended up with was a phase problem, because it was too constant, in the sense that the units of distance were too constant. And the fact is the real universe, every time I move something, it's getting hit by a completely different radiation. You know, it's not photons from the same place. It's not energy from the same place. So there is no phasing. There's no frequency dependency from any one ray. So the pressure is always the same, because even if something, say if something had a cycle this long, and the beginning of a cycle hit this side, and the end of a cycle hits this side, that's the argument. But if you have them in phase, well, then it won't work. So yeah, it's a little bit subtle and complicated, but the idea is you can sort of understand that you really can't escape the pressure from this side. You can't run away from it. You can just do it temporarily. So the simple argument of they're like buffaloes running at you, and it doesn't matter that you temporarily escaped some of the buffaloes, they're going to show up. All right. So where was it going next? I mean, ultimately, I want to get to this gravity thing, because it's just, I just don't know how people can't. I mean, you itemize this and make it so clear, and I just don't know how they can keep thinking, you know, being honest. Let's just say if you're going to be honest, all right? I mean, you have Newton's statement. So if you're going to say Newton was wrong, then please say that. Don't pretend Newton can be right and what you think happens can be right. So Newton says twice the force, twice the motion. You know, 3 times the force, 3 times the motion. So, and motion is just velocity, right? There can't be any concession otherwise. So obviously 2 times the force is twice the momentum, and 3 times the force is 3 times the momentum. it's not 9 times the momentum. It's not 9 times the energy. Certainly by Newton's physics, he doesn't believe in any squared velocity. You wouldn't say twice the force, twice the motion, 3 times the force, 3 times the motion, if you thought velocity was squared. And it meant that you needed 9 times the force to get 3 times the velocity. Alright, so with that context, in the context that Newton did say 9.8 meters per second in velocity over 1 second, okay, not second squared. So again, this is such a, I mean, everybody should, they should be able to just say, okay, I get it. They shouldn't say second squared because it implies that it's some other thing than in 1 second units. It's in time dependent units, and not, you know, for physicists not to admit, yes, it's time dependent units. It just says it right here. It says, doesn't say 9.8 meters per 1 foot, you know, or 5 meters, or even 4.9 meters. It says 1 second. So the force is collected in units of time. I mean, Galileo proved it, and Newton just, you know, basically confirmed it. So this shouldn't be a subject. I mean, it shouldn't be a debate. And so what happens in 1 second? 1 second you get this. Okay, let's just say this is 4.9 meters. 1 second, these two experiments are exactly the same. You have now 1/2 your total velocity. You know, you only want 1/4 of the trip, and you already have half your velocity. Okay, yeah, and you have your first unit of 9.8, and you know in this you're going to get your second unit of 9.8. It's going to be 1 second. You're going to get 1 unit of 9.8, and you're going to have 19.6 in total velocity. All right. So how can people think that in this second, when you're going faster, right? You did these 2 units of distance for free because you got that velocity here. So when you were right here in space, you have 9.8 meters of velocity already. No force needs to hit you. You'll go this far without any force hitting you in the next second. And all you're really getting is this extra 4.9, and you're getting the extra 9.8 over that entire second. I mean, it's just so obvious that I could just do this by counting BBs. I could just say it's 9.8 BBs. Let's just say 10. 10 BBs hit you in this second, and 10 BBs hit you in this second. 10 units of wind. So if we just turned it into wind, you could understand if it's a 30-mile-an-hour wind, I get hit by the 30-mile-an-hour wind, okay, in units of time, and then I'm in the wind again for some more time, or a stream, you know. It's all time-dependent forces. They all take, it's all, velocity is time-dependent, okay, so if the stream has a velocity or the wind has a velocity, and I'm going to convert the velocity, and I'm going to collect it, and I'm collecting it at a rate. And I can't change that rate. Now the only time it gets complicated is obviously gravity is moving the speed of light. So going 5 miles an hour isn't going to mean anything in terms of diminishing the force. But let's say if it was a wind and it was only 30 miles an hour. Well, let's say that at the first second you go 10. Okay. Well, you're gonna know that. Yeah, I can't draw it there. You're gonna know that. In the second, you're already going 10, so the differential is only 20, right? So the 30 is now 20, so it's going to move you less because the differential is only 20. And then when you're going 28 miles an hour, let's say, well, the differential is only 2 miles. So the next unit of time, you're not going to get much of an increase in your velocity. So it's going to just keep diminishing and diminishing, and you're never going to go 30. So, you know. But we're not talking about a 30-mile-an-hour wind. Gravity's moving the speed of light. You're collecting the force that's moving at the speed of light. Just like photons. The speed of force. I mean, I've been saying that for years, and you'd think somebody would catch on and say, you know what, that's really clever. That's what we should be saying. The speed of force. Because magnetism does it, and electricity does it, and light does it, and gravity does it. And those are all the things we call forces. the interactions between electrons and protons. You know, it's the speed of force. It's not the speed of just light. Trying to think if I can think of any other force, but there really isn't any other. I think that covers it. All right, going to take a little break here for a second. But this is the real key argument, and I really have to find a way to enhance this argument where it's really understood that you can't believe there's 4 units of energy. How would the geodesic or whatever's doing it, how could it give something 3 units of energy when there's just no evidence that there's any time for 3 units of energy? That the slope hasn't changed. You're going down the same slope, a 9.8 slope. You can't be getting 3 units of something in the same time. I mean, how can you believe that? How can you believe there's 4 units of time when you only got 2 units? The whole thing only took 2 units of time. You're only in the forest 2 units of time. Again, it's the paint spray argument. I mean, how can you believe, essentially, these people are arguing that I move into a paint spray, and this is how much force this is how much paint I get in 1 second. And then if I move through it for 2 seconds, I get 4 times the paint on me. I mean, 1/2 second, sorry. I move through it at half the speed. I somehow get 4 times the paint. I don't. I only get half the paint. I mean, twice the paint. Sorry. And certainly 3 times slower, I'm not going to get 9 times the paint. I mean, none of that happens in any real world circumstance. So they'll never show me an analogy where this happens. A stream or a wind, or let's see what other kind of mechanism there could be. I mean, it certainly doesn't work with hydraulics. It doesn't work with water hoses. It doesn't work with any fluid dynamics. It doesn't work with gears. I certainly assert it doesn't work with levers or pulleys. So where does this work? Very charry. Anyway. Should have been better than that. That's better. All right, so let's see if I can look at this and think of some other way. I mean, the pointing out that this is for free, right? That I obviously move this distance for free because I gained the 9.8 here. And that I'm just going to get the same thing I got here. I'm going to get just 4.9. So it's the same amount of motion, new motion. It's the same time, same amount of motion, added distance. How could they think this is 3 units of energy? How did I get blown 3 times more here than I got blown here? Again, it's like saying that a boat in the 30-mile-an-hour wind, it only gets 1 unit of energy, in the first second, and then it gets 3 units of energy in the second second. No, it's not. It's not going to be going 3 times faster or 4 times faster. So again, what's the unit of energy, right? This is the whole point is that how can people how can they think that there's a train going down the train tracks and somehow, okay, the train has momentum clearly in this direction, but somehow it has magical kinetic energy, okay, that is in any direction. You know, but some of it's in this direction. Yeah, I don't know. Right, just the momentum part. The momentum part, the MV part's here, and only the squared part is doing this. So that's the funny part, right? I mean, only the squared part is going in these other directions, or not going down the track, and only the MV part is going down the track. I mean, how can that make any sense to anybody? What is a scalar energy? Again, I can keep asking the question, but how would even somebody even conceive of a way of drawing whatever the scalar is? Is the scalar a magical flywheel? I mean, it doesn't exist in the object in any way. How do we understand it molecularly or atomically? How this energy that it has is hidden. You know, it has this hidden special scalar energy. You know, it's just ridiculous. No, all it has is this. It has momentum. It doesn't have anything else. All right. So, and again, so in the Leibniz example, this is a 4 mass, okay, and this is a 1 mass. And clearly these two things don't have the same momentum. This has twice the momentum. So twice the MV is here. Twice. So I know if I throw a bowling ball with twice the momentum, that is, I double its speed, and it's the same weight. Whoa, my battery's burning. Yeah. We know if I throw it with twice the speed, it's going to knock down twice the pins, right? It's got twice the momentum. So we know twice the momentum means something. And their argument is that even though these have completely different momentums, it's exactly the same force. It'll hit the ground with the same force. It'll move the same number of horses. It will pick up the same number of horses. It'll do whatever you want to do to measure energy. It'll make the same amount of heat. So even though the momentums are completely different, this will make the same heat as that. Now, how can that be plausible? Oh, that's right. You can't answer me. You know, no one will ever answer the question. They won't answer it with an answer. They'll answer it with a bunch of gibberish or math or some other crap. But they won't really explain how something with two different momentums could hit a quarterback the same way. Because I know I could just take the same object, a 100-pound guy going 10 miles an hour, a 100-pound guy going 20 miles an hour. I know those two things cannot possibly hit the thing and be the same force. It's not possible for something twice as heavy going the same speed or something the same weight going different speeds to create the same force. How is that possible? All right, so that's a question I haven't asked before. So at least this video was worth something. So that's the simple way to put it, right? I mean, that's a pretty, seems to me, I mean, I can't anticipate what kind of, you know, vocabulary escape hatchy bullshit they'll come up with to escape the logic of it, but it seems pretty good logic. Where the hell is my... Did you see where I put my cleaning substance? Yeah, I lost it already. I do have to reorganize my space. It's gotta be here. I sprayed it. You saw me. Oh, it's right here in front of me. God, I hate getting old. I mean, that stuff always happened, you know, but it only happened like once a year where something was right in front of you and you didn't see it. And as you get older, it happens more and more. Yeah, it really sucks. I don't know whether it's because I can't see. That might be part of it. Or it's just, you know, brain doesn't, you know, it just doesn't work as well. All right, so that's just too good an argument, right? Okay, so I have a quarterback, and I have a 200-pound guy, and I have a 100-pound guy. All right, and they're going to go the same speed. So it's 100 at 10, and it's 50 at 10. Oh, I'm burning the battery again. Shit, those two wires keep hitting each other. I don't want to do that. Anyway, that's the problem with making this rickety system. I just melted the wires too. Oh, wow, those alligator clips are hot. That was a waste of electricity. Terrible, sinful thing to do. All right, so these two things are going to hit. Now, it's just so damn obvious that it's not possible that that could be the same impact on the quarterback, that the quarterback will leave with the same velocity, independent of which one of these things hits it. It's not possible for things with different momentums to have the same impact force. And then, like I said, I could just reverse it and have the same size and double the velocity. I can't hit with double the velocity and have the same effect that one velocity had. How could that be possible? But that's what they're asserting in this example. They're asserting that 4 pounds going 1 unit of velocity is the same energy as 1 pound going 2. Obviously 4 times 1 is 4, 1 times 2 is 2. Obviously that can't be the same energy. It's not the same momentum. How can it be the same energy? How can it be the same impact force? How can it have the same capacity to do work? All right, they're saying it does the same work. Work. That's what they're saying. Yeah, so that's a pretty decisive argument, right? I don't hear any applause. Yeah, no, I don't. You people aren't very helpful. I just have to say that. Yeah, you're not very helpful. You should say, good argument, Gary. Yeah, I think that's a winner. Something, a little bit encouraging, maybe. But no, I don't get any of that. But yeah, that seems pretty decisive, right? How are they going to undo that? Two different momentums can never do the same work. That's the principle. So it's Newton's fourth law. So we'll call it Newton's fourth law. Two different momentums can't do the same work. Can't create the same motion in the universe. All right. Oh yeah, they're repeating some of my good little statements. Thank you. Let's see. Time is a function, not a dimension. Excellent. Thank you. I've been saying that for 10 years. It doesn't work anywhere because KE is not real energy. Very good. Thank you. Yeah. It's a solid argument. Thank you. Yes, it is. It does seem pretty solid, right? But, they always find a way. They always find some jargon and some bullshit to try to evade every single subject. Well, they really don't. I mean, the zip gun argument is pretty decisive, right? I mean, it's just, so what, you could just say, yes, they'll never draw anything. So that's where, there's no point in having the conversation because they'll just do some crap. They'll put some formulas down and that's it. And they won't bother drawing it and show me how it works. But obviously you have this simple circumstance, where you can have two possible things you can do with guns, right? You can put the gun inside of the gun, okay, and you have the same explosive. So it's just the explosive part of the bullet, no bullets. You just have the two guns sealed, so there's no stuff evacuating, and they're just going to fly apart. And all you can expect to get is the recoil. So you're just going to get like 2 joules. Right? So that's it. That's all you're going to get. An equal and opposite reaction. 2 joules. But if I made the same exact explosive and I put 2 bullets in, zip gun. I never made one of these. I mean, I did make a zip gun when I was a kid, where you just have a stick and a pipe and you can, but I only fired it once because it was scared the fuck out of me. But anyway, I didn't make it. Just somebody else made it. Okay, I didn't take metal shop. So yeah, I used to make great I did smoke a lot of pot when I was a kid. He made great rosewood pipes. They were really great. Anyway, all right, so where was I? Zip gun. All right, so you have a modified zip gun, and so you electrically, a little electric wire, you just electrically fire it, and the bullets come out with 2,000 joules. All right, so you have the same explosive, same exact explosive, and in one case you get 4 joules of expansion energy, right? So if I have this thing in the bubble, the joule tank, the energy can't escape. Okay, it has to hit the wall, and it's measurable on the wall. I got 4 joules in this experiment, and I get 4,000 in the other experiment. Same explosive. So how did the same explosive do those 2 different things? Now, what are they going to argue? That there's 3,996 joules of heat here and no heat here? What's going to be the explanation? What possible explanation is there? That these silly numbers are just made up. There's no 2,000 joules. It doesn't exist. There's 2. Same explosion. The matter's moving very fast. You have one atom moving 1,000 miles an hour versus 1,000 atoms moving 1 mile an hour. That's the simple explanation. Same amount of the quanta of energy. Energy quanta. I think Einstein said that. He said light quanta, but I think he also said energy quanta. I mean, how can it be not understood that it's the same energy quanta? It has to be. And the definition of the energy quanta is measurable in units of MV. Ideally, if we know what the smallest mass is, then we can just say it's all in those units. Pukies. Let's call them pukies. The smallest unit of motion in the universe is a pukie. It's a photon, a piece of a photon going the speed of light. So yes, the photon has a pukie mass. A mass of pukie. 1 pukie. Feel kind of pukey. It's the liability of being me. See, being me is really wonderful in so many ways, except for I feel pukey. That part just sucks. Had it all my life, really. I was kind of born feeling pukey. Used to think that maybe it's just some sort of tumor or something. It'd be really cool if they could just cut that out and I could, feel good again. But who wants to have your brain open for that? Super relatable, Gary. Okay, I guess that's okay, rhetoric. I'm not a big fan of super talk, but, it's okay. Super! It's a little bit it's too stylish for me, the word super. It's kind of like marvelous or something. It's just a little too much of a word. Let's see, what else can I go over? Think. Let's see, is there some other way to do it? Yeah, well, see, all of this could be solved. So the circle I drew around there and called it a joule tank, or, it is kind of another one of these curiosities. So just like the Eddington experiment, where they haven't taken advantage of the 400 times better seeing from space, and you don't need an eclipse, and it's a 5-minute experiment. So just like that doesn't make any fucking sense. That after all this time we've had satellites in space, it never occurred to any scientist to point a camera a little bit outside the edge of the sun, which from space is completely black, and look at some stars. It's never occurred to them. Okay. That, in the context of the fact that also they named energy after Joule, and the most famous thing Joule did was the Joule tank, the way of converting anything's motion into heat directly. So you could measure exactly how much energy something has, because you're going to force it all to be converted into one kind of energy, heat, and collect it. A perfectly sensible idea. And there's not a single video, there's not a single anything that actually shows Joule tanks being used to do this. Now, the real flaw in Joule, this is a complex argument, so again, you less than clever people are probably going to be left behind, because it has like 3 steps. 1, 2, 3. I mean, it's all the way up to A, B, C, so it probably will get over your head. But the real problem with Joule's experiments, right? So you have this Joule tank. The thing to do is to make it as direct as possible. So drop the fucking horse into it. Ram something into it that actually goes into the water, and then you can collect all of its energy. But instead, what he did is put a paddle wheel in here, and then run. He actually used 2 weights. So we have 2 pulleys here, and pulley here, just to balance the system. And so all he did was drop weights. He never actually pulled it with a horse or pulled it with a car. Well, he didn't have a car, with a stagecoach or with a steam engine, right? So the whole reason why he did this is he wanted to find out what was more efficient, a steam engine or an electrical engine. The new electrical engines, which obviously weren't very good, because they weren't, they were only taking advantage of part of the magnetic cycle. So they were like 25% as efficient as they became, 40 years later. But anyway, you can't see this over here. Well, too bad. Okay, there's a weight over here. But anyway, and so what he did is drop weights. Now, what you should be able to figure out is that this isn't going to fall at the free fall rate, because it has this string tied to it. Okay, that's pulling on something. So it's going to fall much slower, right? So instead of 2 units of time, it's going to take 6 or 7 units of time. Now, what did I say previously? That's right, it's 9.8 meters per second per 1 second. So every second you get this. And obviously these are all seconds. So obviously it's not collecting the same amount of energy, because it's in the paint longer. So if you understood, if I did this to you with a paint sprayer, and you were on some sort of flexible machine that moved you at a speed, you'd understand that all that's going to matter is how long I'm in the paint spray, right? I mean, that's all that's going to decide how much paint is on me, is how long I'm in the damn paint. So obviously the longer you're in the paint, the more units of this you're going to get. So that's how his experiments confirmed mv squared, is because obviously he was collecting a lot more energy than the free fall impact energy would have been. And you could also understand it that when it hits the ground going really, really slow, there's very little energy going into the ground. Right? So it all went through this string and turned a wheel instead. That's the idea. So the lighter the object I put on it, the more energy hits the ground, and I get a lot less in the joule tank. And the heavier the object I put on it, like a horse, I'll get a much higher percentage of the energy into the joule tank, as long as I make the paddle substantially bigger. So the horse stays in the gravity longer. But that's the, obviously, like I said, why don't they use the concept of the joule tank and just modify it? I mean, with all our modern technology, can you just, he's using wine barrels and insulating them. He's doing, we could do it so much better. Make a really good high-tech, insulated container, and take a really accurate measurement, and just, you just pop one little hole in it, to introduce your force, and, see how much your water collects as heat. Because all the motion will be converted into movement of the water. Every bit of the motion, right, as long as you have the tank deep enough so even a bullet will stop moving. So all of the motion will be collected by the water, and you can just measure, temperatures. And obviously, if I take a 5-ton train going if I take a 5-ton train, a 5-mass object going 10 velocity, and I take a 10-mass object going 5 velocity, I'm certainly going to argue, just like the ballistic pendulum, the joule tank is just going to measure the same momentum, the same heat. It's not going to think that the small one going faster has more energy. It ain't going to happen. And that's why they haven't built the damn thing, I guess, is because they already know it ain't going to work for their theory. It's going to do just what the ballistic pendulum does, which is prove kinetic energy is a fable. Alright, let's see. The word marvelous has always sounded yummy as a word to me. Well, you're a silly woman. What do you know? Well, of course, that's exactly how it works, right? There's a whole category of language that's for gay men and women. And there's nothing wrong with gay men. I'm not saying there's anything wrong with that. I'm just saying that that's what it is. It's signaling. And it's like as obvious as pinkies when you're drinking tea or something. It's bent wristy stuff. It's all that ballet. It's stuff that it's just, if there is any generic hormonal thing, there are certain words that just are trigger words, and that's just the way it is. They just sound girly. I don't know if it's in the word, but the culture, but I don't know if it's what the institute, I don't know how much of that is actually has something to do with trying to think of what the nature of male is. Obviously it's a little bit aggressive. It's reactionary. Women, are more sneaky and plotty. Men are more, let's do this now. Women remember forever, that kind of stuff, Yeah, well, I don't even want to get into a discussion about it. Sorry. Shouldn't even have made a reference to it. This is just a terribly dangerous subject. The burden of proof to account for kinetic energy falls on modern physics, and the K equation is the main evidence they rely on. Yeah, which doesn't mean anything. If the equation's made up, if the formula's made up, telling me the formula is real is just meaningless, and it's just made up. Frankly, we know, the only way they can contrive the squared velocity is to say something like per second, and say per second means I can square something. But we know the acceleration is not a squared function, yet they find a way to make it squared by multiplying seconds times seconds. So even like in the 9.8, it's 9.8 meters per second, and then it's over 1 second. Well, what they do is they forget about the 1, and they end up multiplying the seconds. So they say second squared, even though it's not second squared, it's 1 second. 1 times 1 is 1. It's not second squared. So, in most formulas, you don't multiply the unit itself. You multiply the number in front of the unit. Yeah. And, unless you're doing square geometry, obviously, right? If I'm doing 6 feet by 6 feet and I want to know the area, well, then I say, 36 feet squared. But that's different. I say square feet. I don't say feet squared, right? So that's the difference, right? Saying square feet is different than saying feet squared. Anyway, is the main evidence they rely on. An equation is not evidence or a substitute for collecting energy. Yes, it was certainly not evidence. So obviously the formula makes predictions, and the whole point is the evidence is show me the prediction coming true. So that's why I just keep writing over and over and over again. Their obligation is to show the experiment where it takes 25 times the force or fuel, okay, to make 5 times the velocity. That's their obligation. That's their prediction of their formula. And the same thing goes for the opposite. 5 times the velocity causes 25 times the work to be done. So again, they're saying that if I have a generator at Niagara Falls and I can just make it spin 5 times faster, I'll get 25 times the electricity out of it. And it doesn't happen. This is all these arguments just seem so obvious to me as being, you can't keep arguing this crap. I mean, I have a garden hose, and all I have to do is turn the nozzle so only half the volume comes out, right? So only half the volume of water, all right? Half the amount of water. So 1/2 the mass of water, and it'll come out at twice the velocity. And so right there, I made free energy by their theory. Their theory says I've just made free energy. I made free extra momentum. Force. Work. Kinetic energy. One mass going to velocity is somehow 4 units of energy, and a 2 mass going 1 velocity is somehow only 1 unit of velocity. That's their theory. Well, 2 units of energy. And it's just wrong. All right, there's this weird aura that women have. Yeah, aura. Yeah, well, it's a strange thing, just perspective and age. Because it's only in like the last 10 years where I've sort of given up on women. In the sense of there's just so few, that I'm just saying you can't communicate with them. They're just. It's almost like I look back and I say, why did I bother wasting so much time, thinking it was so necessary that I have this woman thing to, this fuck bag, in the female form. Why did I think that was important? And it's not because I'm less horny. It's just that I've almost gone back to before I was 11 years old, where, you know, I was incredibly sensual, but I had no interest in any particular thing to have sex with. And myself was, you know, perfectly satisfactory. You know, it was just that feeling of arousal was all you needed. You didn't need to participate in something. And so it is just weird, you know, just because I just look back and I say, wow, how was I so possessed? How did they control me so much? How was I so... Because it is so complicated to have a relationship with a woman. I mean, they're such nagging bitches. And, you know, their agenda is mushy and silly so many times. And it's just like, well, anyway. But I'm sure it would be the same if it was a man. I mean, I'm sure if I tried to have a relationship with another man, he'd bug the fuck out of me too. You know, because he's going to have all kinds of, you know, habits that I'm not going to care for. Because, you know, I don't have any, I'm not very traditional. Besides my overt this, I'm not very traditionally male. I mean, I don't want to drive fast. I don't want to fart. I don't want to belch. I don't want to, you know, I don't want to yahoo. I don't want to go yahoo. I don't want to do any of that crap. I don't want to wear a baseball cap. Ever. Yeah. Yeah. I do it a couple of times a year, but, you know. I don't know how that became a thing, really. I just, you know, it's one of those things where you say, they're not very attractive. I really don't get it. It makes your head look like a duck. I understand the sun shielding thing, so yeah, I understand that, but it's like, it's just like wearing an umbrella hat or something. It just, oh please, it's just, you know, you're a man. You don't, the sun's not going to kill you. Well, maybe it is, but even if it's going to kill you, so what? Keep your dignity. Yeah, I'm definitely not a hat person. I'm not a watch person. I'm not a ring person. I'm not a... Yeah. That's how I feel too. I've talked with this girl who is getting philosophy as a major or whatever, and pretty much all of it is this weird humanist something Bernie Sanders stuff. Yeah. Oh, yeah, that's just hilarious. I am a liberal. I mean, I can't ever even imagine ever pulling a Republican lever, because I know they're all just conniving thieves. You know, they want to just give all the money to the rich, and that's all they want. They're just so gooey for it. They want to be, you know, they want to be reborn, you know, as a noble person who just has authority and power for no good reason. I mean, they're just disgusting, putrid things. So I can't, you know. But the liberals have just turned into the wackiest, full of shit, nonsense, drivel. I mean, it's just so bad. I mean, nothing's financed. Nothing makes any sense. Let's bring in more immigrants so we can drive wages into the toilet. And then talk about living wages and I'm for the working people. Well, I'm not really for you, because I'm just going to keep driving your salary into the toilet. Especially in the concept of a world economy, you just can't play the game any other way. You have no choice. If you allow it and you do it, then you're going to have to become China, okay? You're going to have to play as bad as they play. And you'll still fail because your stupid social infrastructure can't give everybody maternity leave and can't give everybody free baby advice and free baby care and free this and free that. It ain't gonna work. paying for kids is fucking expensive, you idiots. Oh, I just keep watching like senior citizens getting picked up with the bus, and I watch the little retarded kids in the yellow buses, and all the money they spend on all this special needs crap. And it's just, no. Just give them money. And let them buy a taxi. Fuck this. Because it's more efficient, frankly. It costs less than trying to create this social infrastructure to protect all these people. But yes, it is horribly disappointing what's happened to the Democratic Party. It just ruined itself. This fluffy baby agenda. Everybody's a special little snowflake. And we'll just give them all billions of dollars and never put them in jail for committing crimes because reward and punishment doesn't work. Well, yeah, it does, you morons. But yeah, it really is bad news. You can't defend either side. There's just nothing. I've never felt so. I never thought there would be a time where there wasn't a dime's worth of difference, but we're finally there. It's not a dime's worth of difference between the plague and polio. Yeah, oh, which one do I vote for? These are like, you stick the dagger in my head from the left side, or you stick the dagger in my head from the right side. I mean, that's all that's really about, right? You poke a nail into my left eye versus my right eye. Oh, that's a great choice. Let's see, which eye do I blink with? That's the difference, yeah. I want to be still able to blink. Wink, not blink. But anyway, yeah. Okay, enough of that. Enough of that conversation. So no more political crap. Let's see. Alright, so yeah, well, see, you probably go way farther than me, buddy. And so I'm not going to agree with everything you're going to say about all this shit. The liberation of women was a good thing. Women being allowed, to be something other than a doll collector. Great idea. But the fact is, they haven't done much with that freedom, frankly. They go to college and then have babies with their college education. And frankly, women physicists, so far, it's hard to find one that's, Sabine Hassenfelder is obviously well studied, so I give her credit for that. She's definitely has a volume of information. But frankly, yes, it's all in subjects that are fucking useless. Dark matter? I mean, come on, how could somebody even research that for 2 years? I mean, it takes you about 15 minutes to say, fuck, this is stupid. That one girl who makes the videos, she has a kind of a girly channel name, but she actually made a video, but she was doing research in quantum computing, and apparently, I didn't watch the video, but apparently she's conceded it's all bullshit. Well, like I said, she's annoying. I hate her guts. I mean, lots of stuff. But I mean, you have to give her credit. She's, she's doing the man thing pretty well. She is a real bitch. But she's creative. I mean, she does all those little music videos. I mean, like I said, and she's pretty damn good researcher. But yeah, I don't think she's drawn any reasonable conclusions. I mean, she does want Einstein's dick way up her ass. I mean, she's just way too enamored with Einstein. Who the fuck is Andrew Wilson, you cunt? You really think whoever Andrew Wilson is, he's interesting or important in some way? God, you're such an asshole. Review his clip. What's this clip? Oh, by the way, does this have something to do with physics? I just wonder about these people. I mean, how the fuck why would they... I mean, is there really somebody called Andrew Wilson that I should know? I mean, it's just amazing. I mean, who the fuck do you think? You think this Andrew Wilson person is like Sean Penn or something? Like everybody should know who he is? Well, Sean Penn's kind of like... that's like dated, right? So you have to say one of these newer guys. Newer guy, Tom Cruise, right? Everybody knows who that name is. You think Andrew Wilson is Tom Cruise? Jesus. And debate is always, what's the point? Video responses are so much better. You take somebody's argument, you play it, you give your full explanation, you're uninterrupted. Yeah, make a video response. I love video responses. Please, somebody, take the stuff I drew and explain where I made some horrible error. I think this battery's probably still there. I really have to decide whether I'm going to buy more nicotine. Really want to quit doing this. It's just such a waste of so much time, this vaping shit. But I just can't imagine life without it. What clip? Andrew Wilson reacted to a man. So is this the fucking goddamn have anything to do with fucking physics, you shit for brain? Oh, God damn. I mean, it's just so stupid. Why the fuck should I give a shit somebody reacting to her video about antinatalism in the first place? But even if she did talk about effelism in that particular clip, which she did, what counter argument do I have to respond to? What's the counter argument? Nature doesn't exist. Life is a simulation. You don't have to kill 30 prairie dogs to have one adult prairie dog. You don't have to kill 50 rats to have one adult rat. I mean, what's the brilliant argument explaining how it's not a meat grinder? So until you can show me some evidence that nature's not a meat grinder, I don't have anything to respond to. You don't have an argument. I mean, even the attrition for crocodiles is 100 to 1. Well, we know it's 100%. They all get murdered. It's just that most of them get murdered as children. Yeah, thank you. Thank you for recognizing this. This channel has nothing to do with that channel. Duh. All out of coffee. I'm all out of coffee. I'm almost out of nicotine and I'm out of coffee. This is time to die. Ugh, it is all so scary. So it is just, well, anyway, yeah, I won't go on it any further, but yeah. Oh, so the original guy didn't answer the question. Involuntary suffering had to shove her nose in it. But anyway. This is just hilarious. So, I mean, I just did a video today. Okay, that was basically a response video to the same kind of silly arguments. So what's like I said, what is the argument? There can't be one. Let's see. He had over 5 minutes to do it. Whatever that is. Okay, just enough. 5 minutes to do it. I don't know what that means. Yeah, he had 5 minutes to answer the question. Yeah, he wouldn't. Hilarious. But again, it doesn't make any difference. I mean, I'm just saying the only argument I want to hear is the argument about how it's okay that gazillions and gazillions of sentient organisms are being horribly murdered every day. And it's just fine because we're doing something so worth it. This is so worth it. I mean, look, I'm doing this. Isn't that worth torturing stuff for? Look, I did this. That's worth it right there, isn't it? Look at that. That's really worth it, right? It's pathetic. Is there something... this 9 billion piles of poo that we've created every day on Earth? Is there something so spectacularly wonderful about it all? I saw a little clip, right? They did somebody with a really nice camera, and it's a bulldozer-y thing, no, a backhoe, picking up garbage and putting it in a truck, right? And there's all these people rummaging through the garbage as it goes, and they're, right where the backhoe is picking up, they're 2 feet away from it because they want to get to the garbage first. That's life on this fucking planet. I mean, you want to torture gazillions of organisms so human beings can rummage through overt filth. It's my theory. It's not worth it. Okay. So enough of that subject. I know this isn't that channel, but did Rachel make a new video? Haven't you already responded to her? But Rachel did made a new video. Haven't you already responded to her? I don't, I'm saying I made 2 videos. I think I've given her argument, and her argument is biblical mush. So fuck it. What? Well, you can't prove my God doesn't exist. Well, I don't have to prove it. I'm not an idiot. I don't believe in theories that have no evidence. So go take your silly theory, shove it up your ass all you want, and I'll call you the Looney Tune you is. You are a dumb, ignorant cunt. There, we're done. I have debated you. I thought her husband was hilarious. It just scares me. I heard they have a kid, and you're just like, that really is disgusting. Yeah, it really should be called child molesting to let these morons raise a kid. You should have to pay me money to hit that, whatever that button is that makes all that crap come on my screen, whatever that little bullshit is. Oh, whatever. It's too ridiculous a statement. The nihilist proved that there is no value in the universe. It doesn't mean anything when things are tortured. It doesn't mean anything at all. I mean, what a pile of crap. Oh, wrong guy. Let's see. Balloon Jesus already debunked Gary. He was afraid to get a voice debate or react. What that says a lie. So just lie. I haven't denied him an opportunity. Where? Show me the email he sent me asking for a debate. Show me. Liar. Ugh, just can't stand these liars. Let's see. Yeah, I'm surprised you have made a new video. Haven't you already made a whole live stream responding to her? Yeah, well, I did both. Didn't I didn't do a live stream. I don't think I did. But whatever. Doesn't matter. I did a live stream. I don't remember. But it doesn't matter. I have responded to the debate, which wasn't a debate about anything except her silly fable and the fact that she thinks it's perfectly reasonable to be a fucktarded fabulist. Okay, so that's it. Yeah, I'm surprised you have made a new video. Haven't you already made a whole live stream? Yeah, whatever. The new video was supposed to have new content in it. So if you watch the video, her husband emailed me and said, I made a video, I'm debunking this, and man, my wife did a great job. And so I figured he's going to say something that might be relevant. And all he did was go, oh boy! Yeah, that's all he did. He went, oh boy. Oh, it was hilarious. But yeah, he chose the clip. And it's just so funny because the clip was just a demonstration how it wasn't on the subject at all. I mean, she basically said utilitarian means you're a selfish asshole. So if you're a utilitarian, all you say is how's it make me feel? So I'll go rape women because it makes me feel good. That kind of thing. Obviously, that's not utilitarian. So that was the first moronic premise. And then the second premise was just my Bible says so. And the third premise was somehow this has something to do with people transitioning. Like somehow I should care that somebody wants to be a woman. Sort of. Mostly. Yeah, I don't care. Did you see the interview with Neil deGrasse Tyson? Interview with what? Who interviewed him? Came out a week or two ago about him talking about reality. Well, that's sort of vague, so I have to know who he was talking to. I mean, his Star Talk show is so obnoxious. I can hardly watch that shit. Responded to the deleted clip? No, I don't know. It's not a response to anything deleted. It's just a response to her part of the interview. Yeah, you really have to provide links, frankly. So just email me a link to something if you think it's interesting. But, there's no point in forcing me to go find the most recent Neil deGrasse Tyson piece of shit. He's the Barney dinosaur of of physics. I mean, he's just. Can everything be funny? Well, I guess everything could be funny if I'm laughing the whole time. Then it's all funny, isn't it? Yeah, if I'm laughing all the time, it must be funny. I wouldn't be laughing if it isn't funny, so it all must be funny. I mean, it's just, it's just so bad. Let's see, nihilists are such clown. The vegan nihilist playing some way out of his league game called Battletoad thinks he can beat it from start to finish, so I watch it sometimes. He's just constantly failing. Well, whatever. Nihilism is just idiotic. I mean, there's no true nihilist, right? I mean, none of them will stick a nail in their eye and explain to me how, I don't care. Being in a degraded condition doesn't mean anything. That can't be bad. Yeah, I'll just cut my head off because, despite my face, I'll prove my nihilism. He's like the type of guy who would correct a child's first words. I don't even know what you're talking about now. Who are you talking about? Oh, brother. I'll send it to you through email instead. Yes, do that. That's what the email address is there for. It is for people to send me links to any kind of crap they think might be potentially useful. But if it's crap, okay, and it doesn't seem potentially useful, then don't send it to me. I'm talking Neil deGrasse Tyson. Okay, who would correct a child's... What do you mean he would correct a child's first words? He doesn't seem like a guy who's organized and disciplined. He seems like the kind of guy who would just say whatever you want because I'm having too good of a time to give a shit. He doesn't seem like he'd be at all interested or concerned. You think he'd care whether the kid's playing with a lawnmower? Yeah, he wouldn't care. He'd be too busy drinking his hot chocolate and laughing. I would correct the kid's first words. I'd be the anal parent lunatic. I mean, I wouldn't let my... It's like toddlers are the scariest thing on earth. The little, whatever it is, 2-3-year-old thing, I guess, 3 or 4, 3, something like that. And, they're so sloppy in how they're walking and they're wobbling all over the place and there's all kinds of concrete everywhere. And you're just like, fuck that. I'd have the thing in some kind of suspended chair, where with training wheels. There's no way I'd let the thing go wobbling around like that. Yeah, well, that's not exactly how I'd phrase it. It's like they can't think outside the academical lingo screw that is shit. Oh, okay, that's a whole different subject. I'm just saying it's not a real thing. Suffering is bad. Oh, we're already done with is ought, aren't we? There's an is. The ought is obvious. Bad isn't good. So yes, let's do good instead of bad. It's too obvious. I mean, once you acknowledge the existence of a negative condition, you're done with is ought nonsense. I mean, if there's a condition and it can be improved, you're automatically stuck with an ought. Well, I love when they do the, if A equals B and C equals W and X is like 4, then 5 equals 27. I mean, that's the, when they start doing that shit, you're just like, oh, this is so desperately silly. Let's see, I always hated, oh, he deleted it already. Oh, she did. Yeah, well, pregnant women was never a beautiful thing for me. Scary, ugly, scary, gross. It's like a giant beer belly. It's like, oh, what the, oh, fuck. Oh, ugh. What the fuck. Yeah. It's like a giant tumor. Just, ew. Gonna fuck a bitch with a giant tumor? Ugh. Well, the whole writing thing is just, it's like, unfortunately, Amanda's book, I just found it tedious rubbish. Just every single sentence is tedious rubbish. You're just saying, yeah, it's all this academic mumbo jumbo, and forget it. I mean, Ben Tarr's book was a little, it wasn't a great read because of just the continuity thing. He just kept jumping from subject to subject a little too much. And a lot of it was the argument against our psychological bias. And, that's just that's almost too circular for me. I mean, it just doesn't go anywhere to argue about the bias, because the bias is really just recognizing, again, that you have a set of facts that don't have anything to do with what you feel. I mean, you can understand something. I mean, you could take a bunch of coronaviruses and make it into a Mickey Mouse, okay, and say, oh, it's cute. But you know better, that kind of thing. Well, anyway, we're really off the subject. I mean, I really do try to stay on the subject, but it doesn't happen too well when I interact with people, because they always force me. They forced me. Yes, now they nudged me in bad directions. Because they can't, and I understand, it's, physics is a little bit, you have to really you have to watch a couple of hundred lectures before you really get what they're talking about. And that's the it's learning curve problem. So that's why it all takes so much time and work and effort. But it should be so easy to talk to physicists about it, because physicists should already know that this doesn't happen. You know? Even the light bending thing, you know, I mean, physicists should know. They know that there's no other force that ever bends a force. You know, you have to use matter to scatter light. You have to, you know, all this kind of stuff. You can't do it with a force. You can't bend it with a force. And it's just so strange that they really fall for this idea that, well, but there's one exception, and that the one exception is twice the bending. You know, that's the part that's really funny. I mean, it's, you know, the fastest thing in the universe. They think it's twice as bent for some reason. So anyway, alright, so I guess I will call it an evening and such, and so forth and whatnot. I have to find my mouse now. Where's the mouse? There it is. Oh. So, yeah, till the next time and such. Let's see how many people are here. 9. I'm always stuck around 9 or 10. It's pretty depressing. Do need to have more participants, but you know, just can't find people who can draw and argue. That's what I need to find. People who can draw and argue. So, till the next time and such, this has been Graph Physics, debatephysics.com, video presentation, and such, and so forth, and whatnot.